present there. So I can see Adityan here. Good evening, Adityan. So I think there is a slight lag in my side. Okay, so let me just do it once again. All right. Okay. So hope everyone can see the video properly and also hear my audio. All right. So let me have a look into the chat box right now. All right. The video is fine. So welcome to Practically Live Vedic Mathematics Part 3. Good evening all. So today what we are going to look is on test preparation using Vedic mathematics methods, and in particular today's session we will name it as the crowning gem because of the special method that we are going to see today. So this is Christmas time, so I'll just try to relate some of the methods that we used with the story of Christmas. All right, so let me have a look into the chat once again. Yes, I can see Adityan there on the chat. Good evening, Adityan. Nice to see you here early. So hope you can hear and see the video properly. If anybody who's attending can hear both the audio and the video, just give thumbs up so that I understand that everything is all right. All right, so I'll just, okay, I got a confirmation from Adityan, thank you. So are there any doubts related to classes taken yesterday or before that? So are there any pressing doubts that you wish to ask before we begin? You can type your doubts in the chat box. So in fact, today's session we will learn more about division techniques. So yesterday Bhuvan was asking on what is the method called as the crowning gem. So today we are in fact going to learn about this method. So this is one of the beautiful methods used in Vedic mathematics for doing division problems. Yeah, hello Mani, good evening, welcome to the class. So Adityan says he has no doubts. Good. So I can see Adityan has been very regular in doing assignments and submitting assignments. So keep it up, Adityan. So others also for the upcoming sessions, you can submit the assignments along with the course material itself. So for today's session, I won't give any assignment, but for the next session of Vedic mathematics, I'll be giving regular assignments which you can practice. All right. So I think we are good to go. So students are being admitted into the class, it seems. So I'll just start very slowly. So in yesterday's session, what we saw was the Sutra Tree. So here is the Sutra Tree that we considered yesterday. And it has 8 sutras. So in Vedic mathematics, actually we deal with 16 sutras. The first 8 are being listed here. So it's a vast subject. That's why we are only taking the first part. And the first 4 sutras we have found applications in various problems. And in yesterday's problems, we also encountered how to utilize sutra number 5, 7 and 8, especially in word problems pertaining to ratios. We found how to use the idea of the samuchaya or the ratios. So once again, for a revision purpose, let's go through the names of the sutras. The first sutra is known as by one more than the one before, and it is also known in Sanskrit as Ekadikena Purvena. Eka Adhikena Purvena. Eka means one, Adhika means more, Purva means the one before. So that was the first one. The second sutra is Nikhilam Navatascharamam Dashataha. So Nikhilam means something related to all the numbers. So this is also called as the Nikhilam Sutra. Nava means 9. Navatascharamam Dashataha. Dashataha means 10. All except the last you should subtract from 9, and the last one you should subtract from 10. So that is the meaning of that sutra, all from 9s and the last from 10. The third sutra is very commonly used for multiplication problems. We learned how to do general multiplication using this particular sutra. And it is also known as Urdhva Tirbhyaga. Urdhva Tirbhyam. So Urdhva means vertical, Tirbhyam means the crosswise direction. Now the fourth sutra is sometimes called as the vinculum method or the bar number representation. It is known as transpose and apply. So we have to transpose and apply. That's why the name Paravartya Yojayet. You have to transpose or invert it and then apply. Coming to the fifth sutra in English is if the samuchaya we were saying it is equivalent to saying the ratio. If the samuchaya is the same, it is 0. Shunyam samya samuchaye. So that is the Sanskrit translation or the actual sutra in Sanskrit. Shunyam means 0. Samya means equal to. Samya samuchayet. So if the samuchaya is the same, then it is 0. So here same, in some context it might be equal to, but in some context it can be something similar to congruency. So in geometry there is this idea of congruent triangles. So there is an application of these sutras to geometrical interpretation or geometrical problems as well. The sixth sutra is known as if one is in the ratio, then the other is 0. 5 and 6 are these sutras are cousins of each other, so they are very related to each other. So in Sanskrit this is known as Anurupye Shunyam Anyat. Anurupye Shunyam Anyat. The seventh sutra is called as by addition and by subtraction. Sankalan Vyavakalanabhyam. So that is the seventh one. We have seen applications of this while you calculate addition in a supermarket bill. You can use this method by addition and subtraction. So you can add some number in order to round it off to a particular figure and then subtract it back whenever you feel it is convenient. The last sutra over here is what is known as by completion or non-completion. So here completion means it could be completion with respect to many things according to the context. So 7 and 8 again are cousins of each other, meaning they are related to each other, and we call the 8th sutra as Purana Puranabhyam. Purana Puranabhyam. Alright, so hope you have understood the names of these 8 sutras. So what we were doing till now is just a revision of the names that we have already seen. So I now see many more chats. Many more students have interacted in the chat box. Hello Avinash, good evening. Hello Aditya Raj. Hi Aditya, good evening. So Mani is asking, is it possible to submit the assignment again? So unfortunately, no. I have closed the submission of the assignments. You can submit maybe next time the course is offered. At that time, I'll be giving much more assignments for you. Yeah. Hello, Murli. I think I'm seeing Murli for the first time, or I'm hearing him for the first time. Hello, Murli. What class are you from? All right. So I think many students are appearing in the chat box. So when you are coming to the chat box, just introduce yourself. So I understand what class you are from, what are your interests. Okay, so Murli Krishna is from the 11th class, it seems. Okay. All right. So today what we are going to see is basically an easy method for doing division problems. So the first set of problems that we will consider here will consider division as an inverse of multiplication. So division will be dealt as an inverse operation of multiplication, which is in fact correct, right? If I multiply 8 with 11, I get the answer as 88. Or this is equivalent to saying 88 divided by 11 is equal to 8. So these both are equivalent. So we will treat division problems as an inverse of multiplication. Now what I want to do is I want to find what is 992 divided by 31. I want to do 992 divided by 31. So for this, I will formulate the problem as follows. 992 is a 3-digit number. So if I multiply a 2-digit number with 31, I will get either a 3-digit number or a 4-digit number. So this number, which is unknown, it will be called as P and Q. The units place is Q, the tens place is P. And each of P and Q are digits between 0 and 9. So let's see whether it is possible to find P and Q using the vertically and crosswise method. So while we learned vertically and crosswise method, we introduced this short formulae VCV, right? Vertical step, crosswise step, and the vertical step. So if we multiply P with 3, I should get the number 9. So what multiplied by 3 will give you 9? That is the value of P. So the value of P that we get equal to 9 divided by 3, and everybody knows it is equal to 3. Everybody knows the answer is equal to 3. Right. Now the question next is it possible to find what is the value of Q in the next step? So next step is crosswise. So in the crosswise step, you have to do P multiplied by 1 plus Q multiplied by 3. That is equal to the middle number. So the middle number here is 9. So we already know P equal to 3 from the first step. So 3 plus 3 times Q equal to 9, or we'll get Q times 3 is equal to 9 minus 3, which is 6, or Q equal to 2. Now the last step is just for verification. We got Q equal to 2. So 2 multiplied by 1 is the vertical multiplication step, and we can verify we are getting the same answer as 2. All right. So this is the method of inverse multiplication. So for doing division of numbers of a 3-digit number or a 4-digit number by a 2-digit number, you can employ this easy method. So what we have used is just an application of vertically and crosswise, and we have used the sutra which is shortened as VCV. We have already seen 2-digit multiplication can be shortened as vertical, crosswise and vertical. So let's do the second problem now. So let me, before continuing, let us write the answer here. So the answer here is 32, and I'll erase this part now to make space for the second problem. Alright, so the second problem is a 4-digit number divided by a 2-digit number. So whenever you multiply a 2-digit number with another 2-digit number, you will either get a 3-digit number or you will get a 4-digit number. So we will formulate the problem again like this. Some PQ multiplied by, oh, I think there is a slight mistake over here. So just change this 31 to 42. So that 31 should be 42. So what on multiplying with 42 will give the answer as 2352? That is a question. So which number PQ on multiplying with 42 will give the number answer as 2352? So again we can use the vertically and crosswise method. So in the vertically and crosswise method, the first step is V. So in the V step, what we are getting is P multiplied by 4. Here you should take two numbers together, 23. P multiplied by 4 should give a number very close to 23. So P multiplied by 4 should be close to 23. Which is the closest number that is less than 23? So if P equal to 1, it is 4. If P equal to 2, it is 8. If it is 3, it is 12. If it is 4, it is 16. If it is 5, it is 20. If it is 6, it is 24. So you cannot take P equal to 6. So what you can do is you put the one value which is less than 23. So what you get is the following. In the answer, you just write the same answer equivalent as 20 with 3 as a carry from the next place. So 3 is a carry operation from the next place. So in that case, you can make the value of P to be equal to 4. In that case, you can make the value of P equal to, sorry, not 4, equal to 5, because P times 4 equal to 20. So let's write P equal to 5. P equal to 5 here. And let's continue with the crosswise step. So the second step is crosswise or crisscross. So crisscross step is P multiplied by 2 plus Q multiplied by 4 should give an answer. Now the answer should be 35. It should be 35 or it should be less than 35. Since it's a even number, you are multiplying some number by 2, it's some other number by 4. So the answer should be an even number. So which is the closest even number which is less than 35? It is 34. So we will put the answer as 34 there. So P, the value we already found it as 5. So Q times 4 should be equal to something. So Q multiplied by 4 should be very close to or less than 14. 14 we got because 34 minus 20 is sorry, it should not be 14, it should be 24, because 34 minus 10 is equal to 24. So from this we understand that Q should be equal to 24 divided by 4, or 6. So let's take this ink and write Q equal to 6. So the answer that we got for P and Q is equal to 56. Now this can be verified again. How do we verify this? We already got the answer as 34 here, so we can write this over here as 34 like this, and the last place is just Q multiplied by 2. Q multiplied by 2 is 6 multiplied by 2, or 12. So it can be written like this. Now always this numbers that are written as subscript should go as carry here. So 2352 is equivalent to writing 20, 34 and 12 with 3 and 1 as carry. So the answer to this problem is going to be 56. So this is a slightly absurd way of doing inverse of multiplication, and this is not the crowning gem method. Now we understand that for doing a simple inverse multiplication, we need to do so many steps. So we need to figure out an easy method for doing such multiplications. Now as a homework, you can try to do this particular problem. Everybody can take this problem in your notebook and try to do this as a homework problem. What is 2337 divided by 73? So again, this is a 4-digit number divided by a 2-digit number. So the answer should always be a 2-digit number. So you can repeat the same steps like this. You can do some inverse operations similar to what we had shown, and then you can find what is the correct answer for P and Q. You can also verify it using the vertically and crosswise method that we have learned earlier. So is this all right? So if you have not understood this problem also, it is fine, because we are going to learn a more generic method which can be understood easily. So we are going to learn about the crowning gem method now. So why is it called as the crowning gem? So a gem is a very precious object, no? So in the subject of Vedic mathematics, the crowning gem sutra is considered to be most precious, because it is possible to solve any division problem easily using this method. That's the reason why it is called as a crowning gem. Now we are going to consider a special case for applying this division method, where we'll take a single digit or a single figure. Another name for digit is figure. A single digit, we'll be taking it as a flagged number. Now a flagged number is a number that is assigned to the units place digit. So a flag digit is a number that is assigned to units place. So in a number system, you have the units place, the tens place, the hundreds place, etc. So this is units, this is the tens, this is the hundreds. So like this you have. Now when you are doing division problems, the units place is taken to be the flag digit. So I'll show the example over here. So I wanted to do this number 209 divided by 52. So for this, I want to write the number 52 like this, with 2 written in the same line as 209, and 5 is written just below the number 2. So here the flag number is equal to 2. So this is what is called as the flag number. So I hope it is clear. So this is called as so you have dividend, divisor, and the quotient and the remainder, right? So the divisor over here is 52. The units place of the divisor is what is put in as the flag number. So the first step in doing the crowning gem method is to create a flag number. In this case, the flag number is 2. From the divisor, the second digit of the divisor is taken as the flag number. Now the second step is to insert a partition. So this is what is called as partitioning. We partition the dividend, this is called as the dividend, into two parts. The part on the right will contain one number less than the closest base number. So the base number over here, it's a 2-digit number. So the base is 10. So 10 has only 1 0. So that is the reason why we put the partition just one number towards the right. So I'll repeat this once again. So hope everyone has understood what is meant by a flag number. So flag number, in this case 52 is the divisor. The second digit of the divisor is called as the flag number. The second step is to draw this partition. So count how many digits are there in the divisor. If there are 2 digits, you have to insert the partition at 1 digit from the right. So in this case, 9 is the number in the right. So 1 digit from 9, you will draw the partition. The next step is to divide the number here. Divide the number 20 by 5. So if you divide 20 by 5, the answer is 4 and the remainder is 0. There is no remainder. So you write 4 here and 0 you will put as a subscript just near the partition. So 0, 9. Now after you do this, the third step is to do the following. You subtract 2 multiplied, 2 is a flag number, 2 multiplied by the 4, which is the quotient. You subtract that from the partition number, which is 0, 9. So 0, 9 minus 2 multiplied by 4. The answer is equal to 1. Is this clear? So the final answer that we get is, if you divide 209 with 52, the final answer is going to be 4 with remainder as 1. 4 with remainder as 1. So I'm going to take just 1 or 2 minutes and see the chat box. So many students are facing doubts regarding this crowning gem method because it's very new to most of you. So what I will do is I'll take many more examples to explain this. It will be more clear with other examples. So you just have to remember 3 steps. The first step is to identify the flag number. So I'll write it here. Step number 1 is to identify the flag number. So the flag number is the units place digit of the divisor. In our case, this example, the flag number is going to be 2. The second step is to divide the dividend. Dividend here is 20 after considering the partition. Divide the portion of the dividend with the non-flag number. So dividend is D here. Dividend with non-flag number. So the non-flag number is 5. So what you have to do is 20 divided by 5. The answer is 4 with a remainder of 0. So you will put the answer to be 0 as subscript over here. The third step is very direct. You just have to subtract the partition number, which is 09, and from that you have to subtract 4 multiplied by the flag number. 4 was the quotient, that multiplied by the flag number. So 9 minus 2 times 4, the answer is 1. So that is going to be the remainder. Alright. So if it is still not clear, what we will do is we are going to consider a second example, and here it is going to be much more clear. So all of you can try this. You can write this problem in your notebook. What is 321 divided by 63? What is 321 divided by 63? So this is the problem. Again, it's a 3-digit number divided by a 2-digit number. So you can apply whichever method you like. The method that I showed in the first slide, or you can apply the crowning gem method. So as we told before, step 1, we have to identify what is the flag number. So anybody, can you put in the chat box what is the flag number that we consider in this particular problem? What will be the flag number? Adityan or Bhuvan, anybody in the chat box? If you know what is the flag number to be used here, you can put that in the chat box. So I'll give a hint. This is the dividend. This is the divisor. So flag number is taken to be the units place digit of the divisor. So divisor is 63. You just have to tell what is the units place digit. Okay, so Mani is asking how to find the remaining number in this number. Okay, so I think what Mani is asking is how to find the remainder. So we are coming to that. Let's do this problem completely, and after that probably your doubt will be cleared. So anybody who understands what is meant by flag, can you write what is the flag number of 63? Yes, the answer is 3, because it is the units place of the divisor. So what you will do is, while writing the problem to solve, you will put 3 at the flag position and you will put 6 in the neighboring position. Now where should I draw the partition line? The partition line will be drawn here, because our divisor is only 2 digits. So you draw the partition line there. Now you divide the number 32 with 6. 32 divided by 6, quotient is 5, remainder is 2. So you will write in the same format as I had shown in the previous slide. Now what you have to do in the third step? So second step, we understand it is the divide step. Divide step. The third step is the subtract step. Third step is the subtract step. So in the subtraction procedure, so let me use a different color here. So in the subtraction procedure, you have to consider this as a single number, 21. So from 21, you have to subtract 5 multiplied by the flag number. So 5 multiplied by the flag number is 15. So you have to do 21 minus 15, which is equal to 6. So the third step of the crowning gem is subtract. Okay, so these are the 3 steps involved. So divide, multiply and subtract. This will be the second step. The multiply step, we have considered the following because of this one in the third step. So third step can be here and this can be the first step. So this is multiply with the flag number, that is why it is called as the first step. Alright, so is this understood to everyone? Okay, so Mani is asking how do we find the decimal number? Okay, that is very easy to find. So if a number is given, the answer is 5 remainder 6. This is also equal to mixed fraction. Number is 5 6 by 63. 5 6 by 63. Now in the calculator you can easily find this out. How to find the decimal number. So if you don't want to write this as remainder, there is also another procedure that we'll see. Directly we can compute the answer in decimal places. But for the time being, our discussion is with the remainder. Is that clear? Is that clear, students? Is it clear to all? So I hope the method is now clear. So let's do some more exercises. These are practice questions for you and we'll try these together. So I want to do the problem 103 divided by 43. So let's see how. So 3 is first of all marked as a flag number. I put the partition at one position here. Okay, so let's go here. Now the next step is to divide the number 10 with 4. 10 divided by 4, the answer is 2 and the remainder is 2. So you will write 2 here. Now you consider the entire number 23. 23 minus 2 multiplied by 6. 23 minus 2 multiplied by 6. 2 multiplied by 3. So it will be 23 minus how much? 6. 23 minus 6 is 17. So the remainder is 17. So the answer for 103 divided by 43 is 2 with a remainder of 17. So you will get 2 remainder 17. Let's go for the next one. This question is 543 divided by 82. 543 divided by 82. What does it give? So first of all, we identified the flag number to be the units place digit of the divisor, which is 2. Then you put the partition here. Divide 54 by 8. Everybody by now must be familiar with the 8's multiplication table. So 8 times 6 is 48. So we can put here 6. 8 multiplied by 6 is 48. So the remainder is 6. 6 you will put here. Now you consider this as a single number 63. So 63 minus 6 multiplied by 2 is 12. 63 minus 12, the answer is 51. So the answer to 543 divided by 82 is 6, remainder 51. Alright. So you need a little bit practice. Those who are looking the answers in the calculator, you will get different answer because you are looking at the decimal. So what you can do is to verify whether these two answers are the same. You change this into mixed fraction. Change this into mixed fraction. What is mixed fraction? You can write 6 remainder 51 as 6 into or 6 51 divided by 82. Now find what is 51 divided by 82. You will get the decimal place corresponding to the same answer. So I hope this answers Mani's doubt. So Mani was asking what is the actual answer in the decimal notation. Now we'll try one question related to long division method. So we'll try this one related to the long division method. So the question is a 5-digit number divided by a 2-digit number. So the answer should be a 3-digit number mostly. It should be a 3-digit number. If it is a 2-digit, if the dividend was a 4-digit number, it could have been a 2-digit number itself. But now since it is a 5-digit number, the corresponding quotient should be at least 3 digits. So let's see how we can do it. The first step, as usual, we will find what is the flag number. The flag number here is 2. The flag number here is 2. Now what you have to do is you insert this partition at one location and then you start with the divide step. So the first step, you identified the flag. Second step is the division step. You divide the number 19 with 6. So 19 divided by 6, the quotient is 3 and the remainder is 1. So you write like this, 3 here and 1 on top. Now consider the number 19. Now we are going to go for the third step, which is the subtract step. So if I subtract 19 minus 2 multiplied by 3, I'll get the answer as 13. 13 will be the answer. So you get the answer 13 like this. Okay. Now what you have to do is, with this answer 13, you again divide by 6. So you come back to step number 2 again. So in step number 2, what you get is divide by 6. So 13 divided by 6, 2 is the quotient and remainder is 1. So you write like this, 2 is the quotient, remainder is 1. Now the next step, you come back to the subtraction step. So this is considered to be a single number, 10. 10 minus 2 multiplied by 2. This 2 multiplied by the flag number 2. So what you get is 10 minus 4 or 6. So 6 is the final answer that you got after this step. So that you divide by the non-flag number 6. The answer is quotient 1 and remainder 0. Quotient is 1, remainder is 0. Now we have reached the last step of the crowning gem method. Now the only step that remains is the subtract step. So what you can do is, you do 0 2 minus 1 multiplied by 2. 0 2, this is 0 2 minus 1 multiplied by 2. The answer is 0. So you will get the remainder as 0. So the remainder is 0. So the final answer to this problem is 321. The answer to this problem is 321. So if you mastered this particular technique, you can solve any division problem within 4 or 5 steps. So I urge every student to take up more practice problems and solve by your own. Only there are 3 steps in the crowning gem method: the multiply, divide and the subtract step. Multiply, divide and the subtract step. So keep in mind these 3. You can easily solve all the division problems easily with this. Alright. So I will just wait for 1 minute before we go on to the test prep questions. So we have 4 or 5 questions ready for test prep. So are there any doubts till this point? I'll just watch the chat box for a minute. Are there any questions or any comments? Be free to tell any doubts that you faced. All right. I think then we are ready to see what are the exercise problems. So today session we called it as test prep. So many competitive examinations are coming forth, and I think from the next session onwards, this Vedic mathematics will not be there. It will be NTSE practice sessions. So I'll be giving some tips that you can use for solving problems that appear in talent search examinations or any competitive mathematics examinations. So I have picked up 4 problems from these examinations and I'm just presenting here, and I will tell you what kind of methods from Vedic mathematics sutras we can apply. So I'll read the question for exercise 1. So Gopal's salary increases by 4% each year. If his salary was 9360, if his salary this year is 9360, what was his salary in the last year? So that is the question. So for any question like this, you would like to assume something, right? So let us assume the last year the salary of Gopal was some X rupees. So X, we call this as an algebraic expression. Algebraic expression, and an algebraic expression just means that it is an alphabet which is either an unknown or a variable. So X is an algebraic expression. So let us assume his salary, Gopal's salary in the last year was X. Now it is increased, the salary has increased by 4%. So by 4% increase is the original salary 1 plus 4 divided by 100. So percent, this is also written as percent, cent meaning 100. So 4 parts of 100, that is the meaning of 4%. 4 parts of 100. So Gopal's salary increased as 4 parts of 100 and his current salary is 9360. So this is the algebraic expression that we get to solve the problem. Now you can easily solve the problem. Take the LCM here. The LCM is 100. You will get 104. You cross multiply. 100 plus 4, that is 104, the LCM is 100. This is equal to 9360. This would imply that x equal to 9360 into 100 divided by 104. Now if you do this calculation, you will get the final answer. Let me just write the final answer. The final answer to be 9,000. Okay, so 9,000 rupees is the salary that Gopal earned in the previous year. So hope the question was clear. So if you have any doubts, you can watch this part of the video once again. It's a very direct question. Now let's go to exercise number 2. So there is a cube which has a side of length 4 centimeters and it is cut into smaller cubes, each having 2 centimeters in length. Now the question is, how many smaller cubes will be there after the process of cutting? So this is also a very interesting question. So each side, this is a cube, it's a 3-dimensional object. Each side is 4 centimeters. This is 4 centimeters and the height is also 4 centimeters. Alright. So what we have done is we have cut the cube halfway, the length and the width as well as the height. So how many cubes will be there? So the principle here is that the volume of the cube, volume of whole cube is equal to the number of smaller cubes, multiplied by volume of smaller cube. So this is the formula that you have to use. So this is, in Vedic mathematics, this is called as Anurupyena. Anurupyena means proportionately. If we cut the bigger cube into smaller portion, a proportional volume is there for the smaller cube. So we know that the volume of a cube is equal to the length of the side multiplied 3 times, right? So here the volume of the cube is going to be 4, the whole cube is going to be 4 into 4 into 4, that is equal to the number of smaller cubes multiplied the volume of the smaller cubes. So the volume of smaller cubes is 2 into 2 into 2. So you can divide these two and the final answer is going to be 8. So this is also easy to see. So the final answer for this is going to be 8. So I hope these two questions are clear to everyone. These two questions were asked as exercise questions in the last week. So hope everyone has understood the idea of these two. So in this particular problem, what we had used is the idea of division and also the idea of multiplication. And in this particular problem, what we have used is the sutra called as Anurupyena. Now let's go to a fun exercise. So here is a fun exercise that is flashed on the screen. So all of you can take 3 minutes, and within this 3 minutes you have to tell what is the value of the gift. What is the value of the gift in question mark? So your time starts now. Is somebody there in the chat box? I don't see any answers yet. It's a kind of puzzle that you see always in newspapers, or maybe some fun magazines. So you have to tell me what the values of the tree is, what the value of the wheel is, what the value of the penguin is, and what the value of the gift is. So it's somewhat straightforward. Only thing is that you have to carefully look into the problem. So first of all, let's start from the tree. What is the value of the tree? Anybody knows what is the value of the tree? So tree plus tree is equal to 15. So the value of the tree should be equal to 1/3, which is equal to 5, right? Yeah, Darshit says the answer is 5. It's in fact correct. So what is the value of the wheel? What is the value of the wheel? Okay, so whenever you are typing the answer, just give, for tree it is T, just write T. For the wheel it is W, so just write W equal to or T equal to. For penguin it is P, for the gift it is G. Alright, so kindly put whether it is T, W, P or G. Alright, so let's find out what is the value of W. So 2 times W plus tree equal to 17. So tree equal to 5. So 2 times W should be equal to 12, or W should be equal to 6. So that is the value of wheel. What about the penguin? So tree plus wheel will be 11. So if you subtract 14 and 11, you will get the answer as 3. So penguin equal to 3, which is in fact correct. Now, if that is the case, what is the value of G? So G equal to tree plus 2 times penguin multiplied by wheel. So I know tree equal to 5. 2 times penguin is 6 and the wheel is 6. So this is 36 plus 5 or 41. So the gift is of value 41, but what is asked here is different, right? Okay, somebody is saying a different answer. Let's wait if there are any different answers. All right, so according to this diagram, we should find what is 2G. 2G equal to 2 times 41, or the answer is going to be 82. Oh, okay. So somebody is saying the pen is not visible. Okay, so let me use a different pen here. Okay, so the tree, I have found the answer to be equal to 5. Okay, let me just use different, let me erase everything. So T equal to 15 by 3 or 5, W equal to, we have found it as 12 divided by 2, which is 6. The penguin, we said it is equal to 14 minus 5 plus 6 or 3. So here the to find what is the value of G, G equal to T plus 2 times penguin multiplied by the wheel. So T we have already mentioned, it is 5. 2 times P is 6. 6 multiplied by 6, which is 36. So the answer should be 41, right? So in the final thing, we have to find the value of two gifts. So 2G equal to 2 times 41, or the answer is 82. All right. So is this fine? All right. So it's almost time to end. So this was the last session in the Vedic math series that we have. So in the next class onwards, this will be NTSE practice session. So you will get special coaching for NTSE examination. So you can utilize many of the Vedic mathematics concepts to make your calculations easier and faster. All right. So I wish you all the best for all your examinations, and also wish you a Merry Christmas in advance, and hope you enjoyed the course, and good that we could interact using this virtual medium in YouTube, and you were very much active in the chat as well. So I'll just wait for 1 or 2 minutes to just collect the comments and also hear your questions, if any. Okay, so I can see one in the chat box. Physics lecturer. Okay, so pranams. So I can see there are students of all age groups who are attending this class. So that's good to see. Okay, so hope everything that we discussed today was at least clear to majority of the students. In that case, I think we can sign off today's lecture. Hope you enjoyed this series, and hope you will remember most of the sutras that we learned today, and also in this part 3. So with that, I conclude. Thank you and namaste.